Hello. So today we are going to discuss about information theory and coding, and the discussion during this presentation will be as per the syllabus prescribed by Visvesvaraya Technological University for the 5th semester Electronics and Communication Engineering stream. So this is our table of contents. We are going to cover what are the prerequisites for this course and an introduction to the information theory, what exactly is an information theory, and how to measure the information content of a message, and how to measure the average information content of a symbol in long independent sequences. Finally, you'll be provided with some multiple choice questions that will help you to assess yourself regarding how much you have learned after attending this particular session. So let us consider the prerequisite. So you are supposed to know exactly how the communication happens. So this is our transmitting end, and we have our receiving end also. So in this transmitting end, initially we have an information source, and this information source can be either analog or it can be a digital. So the information from the information source will be given to the source encoder, and whatever the information, say message M, given to the source encoder should be converted into combination of certain bits. So while converting a particular message into combination of certain bits, your source encoder should make sure that it will make use of minimum number of bits as much as possible. Because if it uses minimum number of bits during its encoding process, we can utilize the channel bandwidth more efficiently. That is the reason why your source encoder will try to make use of minimum number of bits during its encoding process. Depending upon whether your source encoder is representing all the messages with the same length of encoded data, or if your source encoder represents the different messages with the different length of encoded data, we will either call the encoding scheme as fixed length encoding or a variable length encoding. So the source encoder output, which is actually a bit combination, will be given to the channel encoder, and these channel encoders are responsible for adding some extra bits to the encoded data. So now the question is, if the message has already converted into a bit combination, which is actually the output of our source encoder, why do we want to add some extra bits? Because at the source encoder, we said that here it is necessary to convert the message and represent it using minimum number of bits. And if we are using that minimum number of bits here, why again we are adding the extra bits? The reason is very simple. Whenever you are using this encoded data and simply you are sending this data over a channel, at the receiving end, this data might have suffered some error. So at the receiving end, we will not get to know whether the received data is erroneous or is it error free. In order to get that information, our channel encoder will help us by adding those bits, which are called as the check bits, which are helpful in checking whether an error has been occurred in the data that is transmitted through the channel. So the task of our channel encoder is to add those check bits or the extra bits that will be helpful for us at the receiving end in order to identify the errors present in the received message. So our channel encoder output is then given to the modulator. Depending upon the required modulation scheme, we will modulate the data and we will send it through the channel. At the receiving end, the modulated data will be demodulated and the output is given to the channel encoder. So now the channel encoder will make use of only the redundant bit, that is this part of the bit. So if after using this part of the bit, it will check whether an error has been occurred in the data whatever it has received. So if an error has occurred during its transmission, we have two options. Either we can send a request back to the transmitter asking it to retransmit the data. Well, in that case, we will call such coding technique as only error detecting coding techniques. Suppose After knowing that an error has been occurred, if your channel decoder is capable of correcting that error, then such type of techniques are called as error detecting and correcting techniques. So based on which particular technique we are using, either we can correct the data at the receiving end, or else we can send a request back to the transmitting end to resend the data. Now the channel decoder output will be given to the source decoder. So source decoder function is opposite to that of our source encoder. That is, it will convert this encoded data, it will take this encoded data as a input and convert it into the message. Therefore, if we are sending a message M from the information from the transmitting end, then our MCAP would be the decoded information, which is actually approximately same as our M, but if it is erroneous, it will be slightly different from our actual signal. So this is some basic information regarding our communication system. Let us consider the measure of information. So whenever we discuss about a communication system, either we will say that we are transmitting the data at a particular data rate, which is measured in terms of bits per second, or it can be even symbols per second. Suppose if I am sending 1000 kilobits of data per second, I will say that my data rate is 1000 kbps. But if I ask you whether all those 1000 bits of data are carrying any information, then the answer would be no, right? Because some data might be carrying the information and some data might not be carrying the information. Therefore, it is necessary to know how much amount of data is carrying actually the information and how much of data is a redundant data. That is where it is very important for us to measure the amount of information. So we are talking about the data rate. Data rate can be quantitatively measured because we know exactly how many bits we are sending per second. But is it possible to know exactly how much amount of information that we are transmitting? Well, that depends upon how exactly you are interpreting your data. So once if the data is generated, if you want to know exactly the information content in that particular message, then try to make use of certain mathematical functions that will explain you about the information content in the data. If it is possible for you to build up a mathematical equation or a relationship that will tell you the amount of information present in a message, then obviously we can measure the information rate also, similar to our data rate. Okay. So just in order to clear the exact difference between the data rate and the information rate, let me consider an example. If I generate a message like sun rises in the east, and I send this message at a particular data rate, and even that data will be received properly at the receiving end. So after receiving the data at the receiving end, if someone reads that sentence, sun rises in the east, obviously they will say there is no new information present in this part of the message, because everyone knows that sun rises in the east. So even though you are using certain amount of data and certain amount of channel bandwidth in order to transmit that particular message, you are not sending any new information. Therefore, it clearly says that you are wasting the bandwidth without conveying any new information. That is the reason why it is very important for us to measure even the information and not just the data rate, how much data you have sent. Okay. So in order to measure the information rate, let us consider some basic representations. Let M1 to MQ represents messages, that is message M1, message M2, message M3, up to that a source is capable of generating Q different messages. Okay, source is capable of generating the Q different messages, and when it generates message M1, that message will be generated with a probability of P1. Similarly, message M2 will be generated with a probability of P2 and message M3 will be generated with a probability of P3 and so on. Since we have q number of probabilities that are related to q number of messages, the total probability would be equal to 1. That is P1 plus P2, P3 up to PQ is equal to 1. Let us consider that I of Mk represents the information content of kth message. So I represents I information and K represents the number of the message. So for the kth message, the amount of information is represented by I of Mk. Okay. Now here as per the previous discussion, I told you that if you are sending a particular message as sun rises in the east, and if I ask you what is the probability of that particular message, obviously everyone will say that the probability that sun rises in the east is nothing but 100%, because it will never happen that sun does not rise in the east, right? So the probability that sun rises in the east is 100%. But what is the new message that you are conveying with that sentence? That is nothing but 0. Right? So it clearly says that whenever the probability of a particular message is very high, the amount of new information conveyed is equal to 0. Similarly, if I take a day during the summer and if I say that it will rain today, since the chances of rainfall during the summer is very less, I will say that its probability value is very less. The probability that the rain occurs somewhere on May 15th or 16th, its probability will obviously very less. But